All right, so we essentially have a scenario where it says a house initially valued at 275 increases in value by 2% annually. Let X represent the number of years and Y represent the value of the house. Which one of these equations here defines that scenario? So if I take a look at this guy here now, right, we've got to identify what is that 275, what is that 2%, how would this look? If you're strong at this, you can just look down through the list. If you need to write down Y, A, C, X to get an idea of what the rule would look like, that also works as well. Okay? So from this information, what is the 275 out of this list? What is the 275? Is it Y, A, C, or X? Okay, 275000. What about the 2%? So you can't, I know that that's the C value, and I can just convert that into 1.02, meaning when I have both of these things, I have the rule that defines the scenario. So that would mean that this guy would be the correct answer in that case. Okay? So that's the first one that you'll look at that we need to know. Let's skip down past that one. Here's another one that I would probably know for Thursday as well. The value of a video game depreciates 35% yearly. In 5 years, the price of the game will be $10.21. What is the initial price of the video game? So same thing. I always start, right? Y, A, C, X. All right. What's this 35%? Depreciate 35%. What does that mean? What do I do with that? It's a C value. So 35%, what's that actually going to turn into when I want to go use it though? No negatives. No negative, but we're subtracting to get 0.65. Okay? Yeah, I want you to be able to know how to convert this, right? The key word here is depreciates, meaning the value is going down. So we would always do like 100 minus the 35 to get 65 and move the decimal places 2 times to get the 0.65. So 35% turns into 0.65. All right. In 5 years, the price of the video game will be $10.21. Those things are tied together. At a specific time, it will be worth this. What is the 5 years in the YACX? If not, right? X is always going to be time, so X is going to be 5. Now, the last part about this, and the hint I've always given you, is that A is pretty and Y is ugly. When it says in 5 years the video game will be $10.21, is that giving you a Y or an A value? Because it's ugly, right? And because it's tied to a time. In 5 years, it will be something. The Y and the X are kind of tied together, right? Basically saying at a specific time, it is worth this. Okay? So now that means I'm looking for A. And that makes sense for the initial price of it, right? Because A is my starting value. Okay? So you would just solve now. Y, A, C, X. So what does this look like now? I'm just going to plug in the things that I know. I've got 10.21. I've got an A. I've got a 0.65. And I've got a to the power of 5. So in terms of calculation now, what would I do first if I think of order of operations from grade 7? What am I going to do first? So you can kind of do it all in one, or I can go 0.65 to the power of 5, get some sort of crazy number, a 0.11603. So now at this stage when I solve for A, it looks weird, but this is just saying A times 0.11603, and I want to get A all by itself. So if I want to get A all by itself, I am just going to divide 11603, 0.11603. Cancels it on here, and I get an A value. Now I ended up with 87.99, but I know that my A value needs to be pretty. So I'm actually going to say that this guy here, I'm going to round it up and make it a nice number like that. A is equal to 88. That's important that you would round that because in an exam style question for short answer, if you didn't write exactly 88, then I would technically have to mark it wrong. So round that to, this is in your book. Yeah. So, so that's those guys there. Let me just pause this here for a second, see if I can. Pause. So for cell phones, you have two different scenarios, and I wanted to point out the issues I saw the other day. First things first, this guy right there is essentially already done. What I mean by that is I keep saying, right, start them out, but Y, A, C, X. That's if it's written more like this, and I've got to decode from a paragraph. I'm not decoding anything, though. This guy here is actually already giving me the rule. When do I have the rule? When I have both A and C. Those are the most important parts. A is starting value. C is the rate of which it is going up or down. So the A is 300. The C is 0.97. I don't have to do anything with this 0.97. When it looks like this, gents, f of x is equal to this times this to the power of x, it's already done. Yeah. So, all that to say, now he's already done. Let's actually go take a look down at this part right now, because again, this was the confusion that people had yesterday. I'm going to write out y, a, c, x. I didn't even read the question yet or go through the context of it, right? I'm just looking for key things that I can extract from this. Every time I see this, I know I'm going to do that. So Zoe's cell phone was worth $240 on the day she bought it. Awesome. You can write it on here, or you can just write it next to it here. But it's because that's the price the day she bought it. That's the A value. A is always a starting value.
And it's pretty.
C, and it's pretty. That's true. So then it's a rate of increase or decrease for C. And then X is always a time that is paired with a current value. So those two things have a relationship with each other. Okay. All right. So each month since her cell phone, since she bought her cell phone, it has lost 4% of its value in relation to the previous month. Interesting. I'm going to actually write that down here underneath that it says month. Okay. Just to make sure that we're kind of on the same page here. But so it loses 4% every month. Now, from the day they were purchased, which of the two cell phones has lost the most value in dollars? So if I look at the rest of this here, I see the 4%. I know that's going to help me find my C value. So let's do that first. I know that that's going to be 4%. Now, is it gaining or losing 4%? Losing 4%. So that means what does 4% actually turn into to make it look pretty like this guy here? Yeah. We're good. So 0.96 is what I heard Isaac. I don't know what he was hearing. Take the wax out. But 0.96 right here is going to be the actual value. Any questions on that part? I'm really curious to see if anyone's still confused with this because this is the only other roadblock, right? 4% depreciating means 96% is being retained, but I can't use percent in calculations, Bradley. I have to actually turn it into a decimal. Now, here's the only problem. I like this question here as an example. I don't actually like this question here because I find it very confusing that this is one of those exponential functions where you have to figure out when today is. I talked about this the other day. We've got to figure out when today is a very weird concept to wrap your head around. Because all it says is several months ago, let's go back up and read the context. Sarah and Zoe each bought a cell phone on the same day. Since then, the value of each woman's cell phone has decreased. So we have a rule that defines what she bought it for and what it decreased by. So I know full well she paid $300 for her phone, and it's actually only losing 3%. Okay? So time elapsed in months is x, y is value. We already knew that. Time paired with the value. Here is that weird component of these questions. Today, to the nearest cent, her cell phone is worth $257.62. We have to figure out when today is. Such a weird thing to think about, right? So how do we figure that out knowing only that right there? That 257.62, it's ugly. It's a value. So is it a Y or is it an X for Sarah's cell phone?
Sarah's cell phone would definitely be a Y, yeah.
Right?
Good job.
So you have a Y value, you have an A value, you have a C value. All right, now we can actually go ahead and use this. So we've done all our like sort of preamble, our setup. So step one, find today, meaning find X. So this is one where I think the majority of people are more inclined to do trial and error. Am I correct? So we're going to just try and go blank is equal to 300.97 to the power of what? Let's go 3 to start out. Because I know we already have the answer, but I just want to go and show specifically how this trial and error works. So when I calculate that, I end up getting 273 something something something. So 3 cannot be it based on that scenario. So trial and error, I don't want you to erase it if it doesn't work. This is actually part of your calculations, right? Then I'll try another one. I'm going to skip up maybe by 2, so we'll try 5 like you said. 0.97 to the power of 5 times 300. Oh, power of 5 times 300. And I get 257.62. 257.62. So this matches the value we were looking for. So that means X is equal to 5. So that means today is 5 months later. Okay? And time, and these questions and in the next unit, X is always transferable. Unlike the tickets on the Polar Express, this guy is terrible. That's too. That's it. I'm too much Christmas brain. All right, I'm sorry. I just thought it was
Too early for that.
We're not getting into the. All right, moving on. So, more importantly, and this is important for the video as well. Why did after 2 Christmas movies that created such debate, why did Die Hard with a Vengeance, the third one, happen in the middle of the summer in New York? Why did they not keep to the Christmas trend? This is terrible. I could have many more Die Hards as part of the Christmas kind of Rolodex, and I'm very mad about that, and I'm very glad that this is included in this video. Please comment below with your input and assessment on this. Okay, moving on. So just to finish this guy up, and we'll talk about Die Hard after this. Once I get that this X is equal to 5, and I know that today is 5 months later, then I can now use that for Zoe's cell phone. I can then look at it and go, well, Y is equal to A CX. That's the form I'm working in. Y is what I don't know. I don't know what the value of hers is today, but I know that her C value is 0.96, and I also know that the X value is 5 because I just found that, okay? And then so multiplying all that together all in one shot, I get a Y value of 195.69, okay? Now, if you got to there, I'd be so happy. That's like 8 out of 10, 9 out of 10. Kids will often trip at the finish line on this one here. Totally get it. But you've done the bulk of the work, right? So then now it's a matter of what was the question asking again? From the day they were purchased, which one has lost the most value in dollars? So I'm not comparing whether or not 257. I'm not looking at whether or not 257.62 is greater than 195.69, right? I'm not writing that. It's not about what the value is today. It's how much it lost in value. So we start with 300 and subtract 257.62. And we start with 240, right? And we subtract 195.69. and evaluate the value lost, right? Not the other way around. So 300 minus 257.62 gives me $42.38.
Wow.
Okay. Wow.
That's an A-level number.
Owen Wilson, wow.
I think that was it.
And then 240 minus 195.69 gives me something in the neighborhood of $44.31. So that would mean that this Zoe's cell phone would be the one that lost the most value, only by $2, but Zoe lost the most. Okay. And that would be the end of this guy. Now, again, if that doesn't make sense to you, I'm not too concerned about it. My main concern is the beginning of this question, right? Step one, being able to label things out, recognize what I have to solve for, get that time, realize that it is a value that can be used for Zoe's cell phone, plugging it in and identifying what is A, C, and using that rule that I've discovered to figure out what Zoe's cell phone was worth so I can figure out how much value it lost. Any other specific questions on this? Yeah?
Does she lose the most when she has more?
So,
Well,
because this is more, so that's I've subtracted, figured out how much she lost. So she lost $44 on her phone, and she lost $42 on her phone. So she lost more value on her phone.
Okay.
Yeah, so it's just a weird. She started lower, and her phone ended up being of a lower value. But what was more important is that she was losing 4%, and Sarah was losing 3%. So it ended up being kind of close because what you'll notice with exponential functions is when the starting value is like higher, it is going to affect like how much things are going to be removed from. So like 3% of 300 is more than 4% of 240. So if we went a little bit further down the road, I'd be curious to see if this holds true or not, just because of like kind of where it started out. So it may change based on that. That's a good question. So
Cheap Chinese